Alright, so let's find some polar coordinate locations here using this technique. So we need a distance, so let's define a distance of 1 to be about that for our 1 unit length. And for A, we want to go an angle of 5 pi over 3, and that puts us in the 4th quadrant if we're looking at it. It's pi over 3 more than this, so it's going to be somewhere like that. And then I need to mark off 3 units from the pole, and that puts us right about here. So this is 3 units from the pole at the angle 5 pi over 3. Alright, now notice for B, we're going to locate it with a negative angle, so we're going negative pi over 4. And then it's also a positive distance, so at the negative angle pi over 4, we're going to go 2 units in that direction. So we've located the point 2, negative pi over 4. And just remember that would be identical to 2, 7 pi over 4. Alright, for C, we're actually going in the direction of the angle 0 degrees, and we're going to go 3 units out. So in this particular case, if I were asking you for rectangular coordinates or Cartesian coordinates, you would give me the same answer as for polar coordinates. So if our angle is 0 degrees, it looks a lot like that. Part D here, we're going to go, our angle, start angle is at pi over 4, but we're going a negative distance in the opposite, so that makes it the opposite direction, 2 units. Okay, so somewhere about right there, it's going to be polar coordinate point negative 2 pi over 4. Okay, that's the most difficult one to get used to. Once you find your angle, you'll go in that direction for a positive r, but if your r is less than 0, you're going to go in the opposite direction for that distance. Okay, so in this example, just want to point out some things and try and get more comfortable with this idea. So of course, if we looked at the point, polar coordinate for the point 2 comma pi over 4, our angle's pi over 4, we have a positive distance, so we're going to run up in that direction of the angle by 2 units. Okay, notice over here I'm locating the same point, but here we've decided to wrap all the way around and come back up, and that's 9 pi over 4. 8 pi over 4 is a full rotation because that's 2 pi, so that extra pi over 4 is 9 pi over 4. So I've identified the very same point. And here, if I wanted to indicate my angle as a negative angle that doesn't go all the way around, the first angle that meets pi over 4 from the negative direction is a negative 7 pi over 4. And then we're still going in that direction. So it takes us once again to the same place if I go 2 units in the direction of negative 7 pi over 4. Why would we do that? You never know. In this case, if I took and I wanted to make the distance a negative direction, then I have to make my terminal angle in the opposite direction. So if I take this all the way over here to 5 pi over 4, and then I want it to be the point up here to match all these others, I've now referenced a terminal angle that's direction is opposite. So I need to indicate, let's go negative 2 from that terminal angle. And that takes me right back to the same point. So we've got many ways, like we said before, to represent the same point in polar coordinates, whereas there is only one way to reference a point in Cartesian or rectangular coordinates.